So in the worksheet you did today after the test, you discovered that the length times the width always equaled a given number. It always equaled 12 for the first one. And then on the second one, it didn't equal 12 anymore. It now equaled 24. So you talked about this equation right here. And then you were asked to solve for y, because most of the time we don't write things with x and y on the same side. We have y equals something. So this equation, y equals k divided by x, is called the inverse variation equation. And in this equation, we have an x in the denominator. So that means the bigger x gets, the smaller y gets. And you saw that today with your length and width of your rectangle. You know the bigger one of those get, the smaller the other one has to get. So it varies inversely, or not the same. So one gets bigger, the other one gets smaller. So you can write it either way, with the x on top, or sorry, with the x and y together, or the x on the bottom. But either way, k can't be 0. So if you're given a table, tell whether each relationship is the inverse variation. So when you're given a table of both x and y values, it makes the most sense to use this equation right here. Multiply them together and see if you get the same number out. So let's try that for 1a. X times y, so we would have negative 12 times 24. Multiply those two things together, and we end up with 288, negative 288. And then if we multiply 1 times negative 2, we end up with negative 2. Obviously, not the same thing. We don't even need to go any further. This does not vary inversely. As one gets bigger, the other one does not get smaller at the same rate. But now if we try 1b, same thing, multiply your x's and y's together. 3 times 3 will give me 9. 9 times 1 gives me 9. And 18 times a half, or 0.5, also gives me 9. So that means that this relationship does vary inversely, or it has an inverse variation. That 9 that we got every single time is our k. But 1c, we're not given a table of values, so we can't just multiply stuff together. So we have to look at the other definition. This one right here, y equals k over x. If it can be written as something like that, y equals some number over the variable over x, then it's inverse variation. If it can't be, then it's not inverse variation. So let's see if we can write this equation like that. We got to get y by itself and see if we have x on the bottom of our fraction. So the first thing I want to do is subtract 2x from both sides. So I get y equals 10 minus 2x. This right here is a linear relationship. It fits y equals mx plus b. So that means it's not inverse variation. I can't write it to make it look like this. We can't make x go on the bottom. So this is also a no. So we want to write and graph an inverse variation where y is 0.5 when x is negative 12. So that right there is one of our points that we can make with x's and y's. X would be negative 12, y would be 0.5. But in order to find some more, we need to make an equation. We want an equation that looks like y equals some number divided by x. We can plug in values for x down here and get out values for y. But before we can do that, we need to know what k is. So in order to find k, remember we use x times y equals k, which is just if we were to multiply both sides by x here and get k by itself. That's where we get that from. So my x is negative 12, and my y in this case is 0.5. So when I multiply those together, I get negative 6. That's my k. So our equation is y equals negative 6 over x. And now if we want to make an equation, or sorry, make a graph, we need to plot some points. So let's plug in some numbers that give us nice, pretty answers. You can plug in whatever you want. We could do negative 12, negative 11, negative 10, negative 9 if we wanted to. But remember, we're going to divide 6 by that number. So we typed in negative 12, and that gave us 0.5. That's a pretty easy one to graph. What are some other things that we could plug in? I'm thinking negative 6 would be nice. So that way I would get negative 6 divided by negative 6, or just 1. And then another nice one to plug in would be things that go into 6. So maybe like negative 3 and negative 2. If you plug in negative 3, you should end up with 2. And if you plug in negative 2, you should end up with 3. And then negative 1 would be a good one to do. So if we plug in negative 1, we end up with 6. How about if we plug in 0? What would happen? We'd get negative 6 divided by 0. Can that happen? Definitely cannot. So if I plug in 0, we get undefined, something that doesn't work. So now let's go in the other direction. Let's do 1, 2, 3, and 6, because we know those go into this nice and pretty. So if you do negative 6 divided by 1, you get negative 6. Divided by 2, you get negative 3. Divided by 3, you get negative 2. And divided by 6, you get negative 1. So now let's plot these points on our graph. First one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 doesn't fit. So let's move on to the next one that we did. Negative 6, 1. 1, 2, 3, 4, 5, 6, and 1. And then we plugged in negative 3 and 2. And then negative 2 and 3. And then negative 1 and 6. And then that 0 was undefined. It's not possible. Can't happen. And then we went from 1 to negative 6. And then it was 2, negative 3. 3, negative 2. And then 6, negative 1. So we get this weird looking graph that we've never seen before. And what happens is it comes up from negative infinity and it shoots up, and then it does the exact opposite down here. Starts at negative infinity, crosses through all those, and shoots up. So this is our equation for, or our graph for inverse variation. Next thing we're going to do is kind of go backwards. So it says the inverse variation, x times y equals 350. That relates the constant speed, which is x, and we know x is speed, in miles per hour, to the time, y, in hours, this is in miles per hour, it takes to travel 350 miles. So that's where we get the 350 from. And in our case, that's also our k. Determine a reasonable domain and range, and then graph this inverse variation. So a reasonable domain. Remember, domain is our x values. We set up here x values are speed. So we can go 0 miles per hour, totally okay. But anything over like 100 just isn't possible. Even if you're going 100, not a very good idea. So reasonable domain are numbers that make sense for this problem. And then your range is the time in hours, or the y values it takes. So obviously 0 hours isn't going to work. We need some time to end up with going 350 miles. And then we want to graph this inverse variation. Use the graph to estimate how long it will take to travel 350 miles while driving 55 miles per hour. So if we make a table of our x's and y's, let's pick some reasonable speeds. 0 isn't going to make sense because we're going somewhere. 10, we could plug in 10, see what we get out. How about 20? Well, let's just go up by 10. 30, 40, 50, 60, 70, and let's go all the way up to 80, because any faster than that, you're totally breaking the law. So pause the video and fill out the rest of the table and graph those points, and let's see if your graph looks like mine. So this is what I got. I counted by tens, just like you should have, and if you noticed, I didn't make 10 fit on my graph because it would have made everything else really small. But the numbers started to get closer together. We went from 35 to 17, and then 17 to 11. So the difference between 35 and 17 is huge compared to 17 and 11. That's only 6. And then in between here, it's about 3. And then in between here, it's about 1 point something. So the numbers get smaller and smaller. They get closer together, and we can see that by our graph. It starts off really big, and then it kind of smooths out to a nice curve. So if we want to use the graph to estimate how long it's going to take to travel 350 miles if we're going 55 miles per hour, 55 would be about right here. And if I trace that on over, it's going to be somewhere a little more than 6. Could have very well used this table also. Somewhere about 6 hours. So the fact that x times y equals k is the same for all of them, just like this one. 10 times 35 will give us 350. 20 times 17.5 will give us 350. For all of these, it should be the same. We can use this to help find a missing value. So let's say that these are 2 points, x1, y1, and x2, y2. Since they have to be the same inverse variation, we know that this has to be true. Like for the last problem, both of these would have equaled 350. Or for the problem you did with the area, they both would have equaled 12. So if you're given a problem like this, if y varies inversely with x, so because it says this, we know that this is true, and they have to equal the same k. Y equals -4 when x equals 2. We need to find y when x equals -6. So in order to do that, set up this equation. x1, y1 has to equal x2, y2. So the first set of data we're given is this. X equals 2, y equals -4. I'm writing the answer down. So we know just from this side, k has to be -8. So let's use that to find what y would be when x equals 6. So -6 times what we don't know, it's a y value. So we get this equation right here that we all know how to solve. Divide both sides by -6. And then let's simplify this. We end up with y equals a positive number, 4/3. And then you can always double check to make sure that you did this right. We said back here that k had to be -8. So make sure k is -8 if you use 4/3 times -6. And if you multiply those together, you definitely get -8. So one more problem. And this is almost exactly like the problem I just did. Boyle's law states that the pressure of a quantity of gas varies inversely with the volume of that gas. So volume 1 times pressure 1 has to equal volume 2 times pressure 2 because they vary inversely. That means the k for them has to be exactly the same. So see if you can solve for the second pressure right here using what we just did, but now with the story problem. Go ahead and pause the video and see if you can do it. So this is the work I did. And the answer I got was 31 psi, pounds per square inch. So make sure that your answer also makes sense before you're doing it. Here, the volume wasn't that much. The volume was 5.2, so the pressure wasn't that much, only 15.5. As your volume gets smaller, there should be more pressure there. Remember, volume is space. So the less space you have, the more things are compacted together. So your answer should have been 31. And that's it. If you have any questions, make sure you write them down and we'll go over them in class tomorrow.